Facebook has been asking this question for 27 times over the past 6 months. We are given a variable called nums courses that indicates the number of courses I have to take. And we are given the array of prerequisites that indicates the order of taking the courses. If the nums courses is equal to 2, that means we have the course 0 and 1 we need to take. And the prerequisites 1, 0 simply means we need to take course 0 in order to take course 1. We need to return true if we can take all the courses. There is another example that we have the prerequisites 1, 0 and 0, 1. That means in order to take course 1, we have to take course 0 first. And in order to take 0, we have to take 1 first. So you can see we have the cycle here. So there's no way we can finish these courses. From the observation, we can convert this into a graph problem. The number of edges we have in this graph is 5, that corresponding to the number of prerequisites. And we can convert this problem into the first step, building the directed graph, and the second step is to find if there's a cycle. We can perform the topological sorting to find if there's a cycle. The first step is to add a node that has in degree 0 to the queue. The in degrees means the number of edges that goes into the node. For the node 1, there's no edges going into the node, so we have in degree 0. For node 2, we have 2 edges. For node 3, we have 1. And for node 4, we have 2 edges. The first step is to add the in degree 0 to the queue. The in degree 0 means there's no required prerequisite to take the course, so the course 1 is a good starting point. The second step is to pop from queue and then add it to the visit. The third step is to get rid of the node. Because we already visit the node 1, that means the in degree of node 2 will be decreased by 1, so this becomes 1. And then the node 4, the in degree becomes 1 as well. At this point, you'll notice that all the in degrees is 1, there's no in degree 0. So the topological sorting comes to an end. So we can conclude that if the visited node for the topological sorting is less than the number of courses, then we have the cycle. On the other hand, if we have an edge coming from 2 to 4, that means the in degree of node 2 is 0. We can continuously get rid of the node 2. So the in degree of node 1 becomes 0. And then we get rid of number 3 as well. And we keep on track into the visited. So eventually the node 4 will become 0 as well. At this part, we already visit all the nodes. So the visited is equal to the numbers of courses. That means we don't have the cycle. Now we already know how to find the cycle, but how do we actually convert from the array into the graph here? We can create a dictionary called adjacent. The key of the dictionary is the prerequisite at index 1. And the value of the dictionary is the prerequisite at index 0. So this means at the key 1, we have the value 2 and 4, that means from 1 it goes to 2 and it goes to 4. While we are building the dictionary, we can also keep on track on the in degree. So for in degree at index 1, we have 0 in degree because there's no edges coming into node 1. For index 2, we have 2 nodes that comes into the node 2. For index 3, we have only 1 node. And for index 4, we have 2 nodes that goes into the node 4. And here's the Python code. The first part is to build the graph. Basically, we declare the in degree with all the 0 first, and we declare the adjacent variable as a dictionary. Just like I illustrated this before, the key of the adjacent variable is the prerequisite at index 1, and then the value, we keep appending the value. It is the prerequisite at index 0. And then we loop through the in degree array to find if there's an in degree is equal to 0. If it has, then we append to the topological sorting queue. And we loop through all the adjacent based on the node. We detach the node from its adjacent, so the in degree of each adjacent node is decreased by 1. After the decreasing, if we found the in degree is 0, then we add it back to the queue. Finally, we return if the number of visits is equal to the number of all the courses we have. There is another way we can use DFS to find if there's a cycle in the graph. The depth first search means we recursively search from one node to another node if the node has its adjacent. And here's how the algorithm works. Starting from node 1, we can go to node 4. Now, from the node 4, we cannot go anywhere. So we return to 1, and then we go to 2, and then 4, and then come back to 2, 3, and then 4, and then come back to node 3, back to node 2, and then finally goes back to the original one. In the DFS, while we are recursively goes deeper and deeper, we mark the first node 1 into the stack and into the visit. And we can go from 1 to 4. So we add node 4 into the stack and the visited. And we return false if there's no out edge. So false means there's no cycle. And that makes sense because from 1 to 4, there's no cycle. And now we goes from 4 back to 1. We pop 4 from the stack. And then we go to 2. We mark 2 into the stack and into the visited. And then we go to 4. We mark 4 into the stack. Because 4 has already been visited. So we'll go back to number 2 and then return false. And we pop 4 from the stack. Now we can go from 2 to 3. We add 3 into the stack, into the visited as well. We can go from 3 to 4. We add 4 on the stack. Because it's already been visited, so we return false to number 3. And we pop 4. Now we are back to number 3. We need to go back to number 2 as well, so we pop 3 from the stack. From 2, we know we need to go back to 1, so we pop 2. And eventually, we pop the last element. If there's a cycle, we can clearly see that if we put 1 at first into the stack and into the visited, 1 can go to 2. So 2 into the stack and into the visited. But 2 can actually go back to 1. So while we are inserting 1 into the stack, we need to check if the node is already in the stack. If it is, we need to return true. That means we have a cycle. And here's the Python script. We have 2 base cases here. If the node is in the stack, that means we have a cycle. If already visited, then we return false. Other than the base cases, if we are on the middle of the returning and we detect if there's a cycle, we need to return true to the previous step. Otherwise, we return false. Outside of the recursion function, we declare the visited as a set, a stack as a DQ. And here's the way we build a graph, storing the graph into the adjacent variable. If there's a cycle, that means we cannot finish the courses, so we return false. Otherwise, we return true. If you like this channel, please click like and subscribe. Thank you.